This section says, I can find the x and y intercepts from an equation in factored form. Factored form is handy because it makes the x-intercepts really simple to find. The y-intercepts take a little bit of an extra step, so we'll go through how to do that too. But the x-intercepts are pretty easy to track down. In this first example, the x-intercepts are the things that cause this over here, y, or f of x, to be 0 when you plug in this particular value of x. So what values of x could you plug in to this to make it the answer 0? And the way that you can think about that is, since they're being multiplied, this group is being multiplied by this group, all you have to do is make one of the groups equal 0, because 0 times anything is 0. So you just have to find a way to make one of these groups equal 0. And one example would be if you plugged in negative 2. If you plugged in negative 2 here for x, then negative 2 plus 2 is 0. This whole group is 0, and that means this whole equation is 0. So negative 2 is one of your answers. The other one that could make this group over on the right become 0 would be negative 13. So if I plugged in a negative 13 plus positive 13 is 0, that will make everything become 0. So those are the x-intercepts. And we're actually going to keep going with the x-intercepts for a second. I'm going to jump down to this last one. Y equals x minus 4 and 3x plus 13. For this first group, plugging in a positive 4, so then we have 4 minus 4 is 0, is going to be one of the x-intercepts. So x could equal 4. The other one, though, is not quite as simple. If we want to make this whole thing equal 0, I'm actually going to write out on the side this equation, 3x plus 13, and I'll literally set it to 0, because there's not really a quick shortcut for this. If I subtract 13 from both sides, I end up with 3x equals negative 13. And then if I divide both sides by 3, I get x is equal to negative 13 thirds. If you were to round that off in your calculator, negative 4.3 repeating, you could do that. This answer is actually going to be the best way to leave it, to just leave it as a fraction. So negative 13 over 3. The reason this works is if you were to plug in negative 13 over 3 in for x, negative 13 over 3 times 3 will cancel out that 3 in the bottom, leaving you with negative 13. Negative 13 plus a positive 13 would go to 0. So you would make that whole group go to 0 by plugging in that value. So these are the two x-intercepts there. Now let's go back and look at y-intercepts for both of these problems. The y-intercept says, I don't want to make y 0, I want to set x equal to 0 and see what y is, what f of x is. So I want to know what f of x is when I plug in 0 for every x I see. So if I have 0 plus 2 and then 0 plus 13, I really just have 2 times 13, which is going to be 26. So my y-intercept is equal to 26. And I might even want to write this not just as x, but x-intercepts, so that I know that I'm talking about the intercepts. Scroll down, the same process applies here. If I want to figure out my y-intercept, I'm going to take 0 and plug it in for every x I see. And when I do that, I have 0 times a negative 4, which is, or 0 minus a negative 4. Excuse me, 0 minus 4, which is just negative 4. Times, over here, 3 times 0 is 0, plus 13, just 13. So then negative 4 plus, or times 13, excuse me, negative 52. So your y-intercept is equal to negative 52. And so that would be x, y intercepts, and you just repeat that for all of these. The only one that you might be a little bit tricked by is this floating x here. Just think of that as its own separate group, and that should hopefully help you. Good luck.